Hi guys, myself Sachin. I'm from SVCE Bangalore, 4th SEM ISE. Now we'll discuss about kernel modules in operating system. Introduction to kernel modules. Kernel modules are small pieces of code that can be dynamically loaded and unloaded into a kernel of an operating system. They extend the functionality of the kernel without the need to reboot the system. Kernel modules are an essential part of modern operating system, allowing for flexibility and modularity. The kernel contains many modules, some of which are device drivers. In this, a kernel module is defined more broadly than a device driver because it can be used to perform a variety of functions, including management of functions, common functions shared by other modules. The next point is kernel modules. Kernel modules are pieces of code that can be loaded and unloaded into the kernel upon the demand. They extend the functionality of the kernel without the need to reboot the system. A module can be configured as built-in or loadable. There are several advantages that come with using the kernel modules. The first one is the kernel does not have to rebuild your kernel as often. This saves the time and prevents the possibility of introducing an error in rebuilding and reinstalling base kernels. It is easier to diagnose system problems. A bug in a device driver which is bound into the kernel can stop the system from booting at all. It can also be really hard to tell which part of the base kernel caused the problem. Now we'll see about functions of kernel modules. The first one is device management. To perform various action processes and require access to peripheral devices such as mouses, keyboard, etc. They are connected to the computer. A kernel is responsible for controlling these devices using device drivers. Here, a device driver is a computer program that helps or enables the operating system to communicate with the other hardware device of the operating system. A kernel maintains a list of all available devices, and the list may be already known and configured by the user or detected by the operating system at the runtime. Now we'll see the benefits of kernel modules. Kernel modules enhances the operating system's functionality by adding new features or device support. They allow for the addition of drivers or file systems without modifying the existing kernel code. Kernel modules enables the system to be tailored to specific needs, reducing the overall size and complexity of the kernel. The kernel consists of a set of kernel modules that interact with each other, each performing a specific interaction. Some kernel module perform software function exclusively, while others, such as device driver, control the operating system of the hardware components. A purpose for writing a kernel module is to provide the middle layer of the code, thus increasing the efficiency of the system. Now we'll see the types of kernel modules. The first one is device drivers. Kernel modules that enables communication between the operating system and hardware device. The next one is file system modules. Kernel modules that provide support for different file systems, allowing access to various storage formats. The next one is network protocol. Kernel module that implement networking functionalities such as TCP or IP or UDP. Now we'll see about monolithic kernels. In a monolithic kernel, the same memory space is used to implement user service and kernel service. It means in this type of kernel, there is no use of memory usage for user service and kernel service. As it uses the same memory space, the size of the kernel increases rapidly over the size of the operating system. The execution of process is faster than the other kernel types as it has separate spaces for separate user and kernel space. The next type of kernel is microkernel. A microkernel is also referred to as the UK, and it is different from traditional kernels or monolithic kernel. In this, user service and kernel service are implemented into two different address spaces, user space and kernel space. Since it uses different spaces for both the service, so the size of the microkernel is decreased, and which also reduces the size of the operating system. Microkernels are easier to manage and maintain as compared to monolithic kernels. Still, if there will be a greater number of system calls and context switching, then it might reduce the performance of the system by making it slow. The next type of kernel is hybrid kernel. Hybrid kernel are also known as modular kernel, and it is combination of both monolithic kernel and microkernels. It takes advantage of the speed of monolithic kernel and the modularity of microkernel. An hybrid kernel can be understood as an extended version of microkernel and monolithic kernel. These kernels are widely used in commercial operating systems such as different versions in Microsoft Windows. The next type of kernel is nanokernel. As the name suggests, in nanokernel, the complete code of the kernel is very small, which means the code executing in a privileged mode of hardware is very small. Here the term nano defines a kernel that supports a nanosecond clock resolution. Next we'll see about exokernels. Exokernel is still developing and is the experimental approach for designing an operating system. This type of kernel is different from other kernels as in this resource is protected and kept in separate from the management, which allows us to perform application specific customization tasks in the operating system. Loading and unloading kernel modules. Kernel modules can be loaded using the keyword insmod command, which inserts the module into the kernel. Once loaded, the kernel module becomes an integral part of the kernel and can be accessed by the other components. Unloading a module is done using rmmod command, which removes the module from the kernel. To load a kernel, we can use an keyword insmod insert module command. Here we have to specify the full path of the module. The command below will insert the speed step module. To unload the kernel module, we use rmmod remove module. The command will show the following example. Will unload or remove the speedsteplibrary.com command module in the operating system. Now we'll see the dependencies and interactions of kernel modules. Kernel modules can have dependencies on other modules or other kernel components in the operating system. These dependencies define the order in which modules should be loaded or unloaded in the operating system. Interactions between modules may require proper configuration to ensure optimal performance and compatibility in the operating systems. Now we'll see about module parameters in the operating system. Kernel modules can have parameters that can be configured during the loading process. These parameters control the behavior of the module and can be modified without recompiling the module. Module parameters provide flexibility and customization options for the system in the operating systems. Now we'll see about debugging and troubleshooting in kernel modules. Debugging kernel modules can be challenging due to their close integration with the operating system. Tools like print case statements and kernel debuggers are commonly used to diagnose the issues in the kernel modules of the operating system. Troubleshooting involves identifying and resolving conflicts, dependencies, or compatibility problems. Kernel programming brings its own unique debugging challenges. Kernel code cannot be easily executed under a debugger, nor it cannot be easily traced because it is a set of functionalities which is not related to a specific process. Kernel codes can be exceedingly hard to reproduce. Thus, destroying much of the evidences will be used to track them easily. The next point is, when a kernel module containing bugs is inserted into the kernel, it will eventually generate a kernel oops. A kernel oops is an invalid operation detected by a kernel and can only be generated by the kernel. For a stable kernel vision, it almost certainly means that the module containing a bug after the oops appears, the kernel will continue to work. The next point is, very important to the appearance of the kernel oops is saving the generated message. As noted above, messages generated by the kernels are saved in logs and can be displayed with the command. The next point is, to make sure no kernel message is lost, it is recommended to insert or test the kernel directly from the console or periodically check the kernel messages. Noteworthy is that an oops can occur because of a programming error, but also because of hardware components. Now we'll see about security considerations. Kernel modules have direct access to the system resources, making them potential targets for malicious activities. The next point is proper permissions and access control should be implemented to prevent unauthorized module loading. The next point is regular updates of security patches should be applied to minimize vulnerabilities. Now we'll see about community and open source contributions in kernel modules. In kernel modules are often developed by the open source community, contributing to the overall improvement of the operating system. Open source projects like the Linux kernel have a vast ecosystem of modules created by the developers worldwide. Collaboration and sharing of knowledge in the community leads to advancement in kernel module development in the operating system. So now we'll see about the conclusion. Kernel module offers flexibility, modularity and extensibility to the operating system. They enhance functionality, provide device support and allow for customization without modifying the kernels in the operating system. Understanding the kernel modules is essential for system administration and developers working with the operating systems. Thank you guys. We'll see you in the next session.